Hi, everybody. Welcome to another episode of Advent of Code in Kotlin, Monday edition, I suppose. New week, new challenge, more chances to solve a couple of puzzles. If you're in the chat right now, come and say hello. Make yourselves known, whether you are watching on Twitch or on YouTube. Come on and check in. Very curious to hear, as usual, how you felt about today's challenge. What your thoughts were when you first opened the page, maybe this morning. And maybe, how easy or difficult it actually felt to solve it. It's so nice to see all those hellos in the chat over there. Delightful. I did brew this tea just mere minutes ago, so I'll have to take very, very small sips. It's very hot, but it will accompany me over the course of the next hour or so. So that's gonna be great. Let's see here. Oh, we got. Look at that. Easy, done faster than you, Seb. Congratulations. That's awesome. It did take me a minute this morning. My thoughts were, why am I waking up at 5 a.m. for this? But you did wake up, and I hope that you solved it. So I hope it was still a good time. Okay, now this one I'm curious about. Two-liner in Kotlin? Do you have that? If you have that solution handy, make sure you put that in the Kotlin Lang Slack if you haven't yet. That seems like something I would want to examine on stream. That sounds great. Wow. I'm sure the code that you'll see in today's episode is going to be a smidge longer than 2 lines, but we'll see how it goes. I just like the wave emoji. We'll keep that as is. I choose to interpret this one as you're in the flow, which isn't that nice. Some folks say I took longer than I thought to do the data type. Easier than yesterday. That's something that I'd probably agree with. Oh, I meant only part 1. I see. Or, of course, 2 very long lines, depending on how you look at it. Okay, but overall, it seems that, attitudes, besides, having to wake up at 5 a.m., seem to be pretty okay towards this one. So I'm very much looking forward to puzzling this one out on stream today as well. And it's not just going to be me. As usual, we have a wonderful guest who is going to be joining me. And today, that is none other than Dima Kandalov. Hi, Dima. Welcome to the show.
Well,
how are you doing?
I'm good. How are you?
I am excellent. December is always my favorite time for reasons of Advent of Code. Pretty much purely for reasons of Advent of Code. I'm not a huge fan of all the snow outside and not being able to, take public transport because the buses stop working the moment it snows. But apart from that, this is a pretty good way to even it out, the good parts with Advent of Code. Yeah. So I assume you solved this problem today by yourself, right?
Yeah.
And how did that go overall? What were your initial feelings?
Well, like what you said, easier than yesterday, right? Definitely.
Fair enough. Yeah. I think we'll. You had a very nice idea earlier, which was that rather than just look at a couple of solutions, we could actually start from a blank slate today, and do a little bit of pair programming, which I thought was a really nice idea.
Yeah, I just thought why look at 2 solutions? One when we could combine our solutions, and we won't know how it's gonna go, right? It's gonna be fun.
Yeah, definitely.
I think part of it, the whole Advent of Code, it's ethics around it, showing off your solution instead of oh, let's come together and just do something, learn from this experience. It's what is the goal of this exercise, right? That should be your first question. And everyone I think like jumps to conclusion that to solve the problem, but you could choose a different goal, right?
Oh yeah, 100%. That's it is probably the beauty about advent of code, is that there are so many different ways of how you can approach it. Whether it is exchanging with your colleagues about like different languages, or different approaches in the same language. I personally, so a friend of mine is doing these exercises in Rust, and I always learn something new about programming as a whole and about Rust in particular, which is always a really, really great time. I do want to take just a very brief moment. Careful, there's going to be a light page up ahead. We'll just briefly mention again that all of this is part of a larger campaign of Advent of Code in Kotlin streams. We're doing 12 of them, and we have a different guest every day. And most importantly, of course, there are plenty of learning opportunities for you, as well as ways to compete with other people, but also to just win a couple of prizes if you just participate. So it is not too late to join any of those leaderboards. Please make sure you only join one. Then you will be able to opt into winning some Advent of Code specific prizes, which I'm quite excited about. As usual, I will also very briefly only shout out the fact that we do have a bunch of different resources, because it is day 4. You've probably heard me do this spiel on a couple of the previous days, but it's still worth taking a look in case you haven't yet. Do have a snow-related info here. Munich was even worse with the snow than Augsburg. Public transport failed completely. Yeah, this is currently, I think we're hitting unprecedented levels of snow out here, which, you know, all the more reason to stay inside and do a little bit of coding. Cool. All right. Well, with that out of the way, I guess there's nothing to really stop us from getting right into the problem. We did not practice anything in advance, so it'll just be a good time, I guess, of two fellas trying to figure out how we could combine a solution. So hat goes on, and we'll do a little bit of a dramatic reading. And unlike usually, where I already have my solution prepared, I think I'll actually have to pay a little bit of attention while I do my dramatic reading. We'll manage. Okay, so it is day 4. Scratch cards. The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful cards. Oh, hello! The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure, I just operate the gondola lift. That does sound like something we'd have, though. This is Island after all. I bet the gardener would know. He's on a different island, though. The small kind, surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat. And you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point of that card. For example, we have a couple of cards. In the above example, card 1 has 5 winning numbers: 41, 48, 83, 86, and 17. And the 8 numbers you have, that's 83, 86, 6, 31, 17, 9, 48, and 53. Of the numbers you have, 4 of them, 48, 83, 17, and 86, are winning numbers. That means card 1 is worth 8 points. 1 for the first match, then doubled 3 times for each of the 3 matches after the first. And we have a couple of other cards with 2 winning numbers that are worth 2 points, 1 winning number gives 1 point, and no winning numbers. So those have no points. In the example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful cards. How many points are they worth in total? Okay, all right. We have our challenge set out for us.
One thing I would like notice is that, maybe in real world it's worth understanding why we're doing what we're doing, and here I just wonder why Elf asking us, if he wants the points, just like, oh well, where are you gonna get your prize? Maybe take your cards to that place.
Yeah, just dump it all on the counter and be like, here's my tickets, you figure it out.
Yeah.
Maybe they have a policy where if you bring them a ticket with no winning numbers, it voids all. I think there's weird rules on island.
Sure.
But they do seem to have a working lottery system, which is already a pretty sophisticated for just a floating thing in the sky. Okay, so I guess we can try figuring out what it is, or what kind of approach we might want to take here. Do you have any first instincts, constraints, or anything else before we jump into code?
I think that Mai yesterday mentioned a useful thing to look at the input, just to eyeball it. And I think also sometimes maybe another question to ask, can we solve it manually quicker? Why write a program if we're automating it just for one single input?
Very good.
Given some, I think, problems, if you start from the top row, I start from the bottom, we'll finish before we write code.
We'll give everyone in chat one of the cards,
yeah.
And then they can go for, and we can just go for parallelization.
Yeah.
I think, though, at 194 cards that are also marginally longer than the example that we just had, which was a slightly more compact. Not sure if that's feasible, but it's a good first move.
Yeah, but I guess it feels like we should be able to process this line by line, right?
Yeah,
it's the most natural approach. Yeah, parse lines.
Yeah,
and then figure something out.
Very cool. So for convenience, I think I'm just gonna steal this, and we can just head over straight into IntelliJ over here. So again, if you're tuning in for the first time, we are using Code With Me, which is the collaboration part of IntelliJ. So you can see that Dima can write something, and that'll show up on my screen, and Dima also sees the same code, obviously. Great. Since we're going line by line, really all that we need right now is just a single card, I guess. No need to spend too much space here. The only setup that we've done is we've put the actual input as well as the test input into our into the text files, and then we read those. Okay. All right. So, do you want to kick us off, or how do we do this?
Sure. So let's run what we have. Right. Oh, if you show the run window, we'll see that this code.
Make sure that I have the run window. I sure hope we'll do this, and then we'll keep it open.
Yeah. So I just ran this just to see that the file can be read. I like fast feedback. That's why I was just can we read lines? Yes, and we'll just print them all. Also, I think I'll try and keep it a bit more functional, like ideal as a single expression. Right.
Okay, yeah, sure. That seems
the
fine.
the next thing we want to do is probably parse this line and split on something. I can see we could split on spaces or
yeah, we also got colons. Yeah.
Yeah. What do you prefer?
We can do both.
Regex? Oh, yeah.
We can actually. So split actually allows you to do just define multiple delimiters.
So I'll do this, right?
Yeah. So we might as well do that. Very nice. And we already have 3 parts.
Cool. So we have 3 parts. We don't care about the first one, and we do care about second and third, right?
Yep. So, I mean, we could just, depending on how much more we're going to do in this map, we could quite literally just have an underscore for the first one, and then the first would be winning numbers, and the other one would be like our numbers, I guess? Something like that?
All numbers. I mean, they're all our numbers.
Well,
yeah.
Well, but like, okay, but how would we call it? Didn't it say it's the numbers? It's the numbers you have.
Okay, fine. Fair enough.
Yeah,
you convinced me.
Okay, cool. So I guess yeah.
Yeah. So then those numbers are not numbers yet, though, right? So if we just print winning numbers, it's a string, so we need to split this as well. So we could do on the space. Then we want to map it to int. I think it will be empty.
There certainly will be.
Yeah, so it will be what we're going to do. No, trim not going to work, right? We need to do int. Let's see what happens.
Yeah,
right? Blows up.
Yeah, so this explodes because we got empty strings. So we can just add a filter in the middle here, and we'll make sure that it's not blank. Yeah. Not empty, I think, would be okay here. But we might as well keep it this way.
Cool. I also can see that there is a yellow thing here on it.
Ah.
Yeah, so at this point, I would say maybe I'll go to here and rename this to line so that we don't have the conflict.
That's a good move.
Yeah, so now we have winning numbers.
Yeah, so these I guess so we can make this the winning numbers text, and I'll just rename those. And then I guess we can turn these into the actual winning numbers. And then I suppose we have pretty much the exact same code for our numbers. Personally, I would say probably introducing an abstraction here would be overkill between the two.
Yeah.
But
yeah, well, let's write something and then refactor it. So then I'll
change great.
Numbers text, and then I can't see quite what's happening. Let me do multi-edit if I can, like this. Our numbers.
Very nice. Okay.
So we can do winning numbers to our numbers. So this will be a parse stage. So we can see in the output. I think it worked.
We'll see. We have So we have a pair overall, and then this is one array, which are now also integers, which is nice. And then we also have so we have 2 lists of integers.
Yeah.
Which is nice.
If we're doing like functional style, I would maybe do less here. It's a bit of a waste, of course. So, oops. Did it not copy? So basically we'll have winning numbers and our numbers, and that's it, right? Oh, sure. To destruct.
Yeah.
I wish there was an idea, you just press F1 and it's like, okay, fine.
Agreed.
It's like winning numbers.
So this one I actually,
also maybe println.
That's what I would do. That works. Yeah, this is also exactly what I usually do. What I really like is someone's mentioning here. Instead of filtering blanks, I used a chunked and then map with a trim, and that's exploiting a property of the input, because the input is like each number is always like, well, it's 2 digits long maximum, but they're always aligned. So you can, as long as you have like a window of 3 elements. Or a chunk of 3 elements, you could also do that.
Should maybe try it.
We'll add this. We'll add this as a to-do. That's how real refactoring works, right? red green refactor or something. Okay.
Yeah, so I mean, like in general, I think the best approach for this is just get something working, submit, and move on. But we'll do more. So yeah, what was the thing? We want to count how many winning
So,
numbers are in
yes.
our numbers, right? So we want to count.
Exactly. Yeah.
And type
Sorry.
in count and it in our numbers. That's what we kind of want. Oh, but these are wait, doing something wrong. I see the type. Oh, of course, should be map, I believe.
That seems fine. Okay.
Yeah, so we got the counts now, right?
Great. So I mean, at that point, instead of also, I guess you could just change that
on each. Yeah, I'll do on each. Yeah, that's better.
Sure. That works. And I guess all that's left is sum, right?
Sum.
And then,
isn't it like more complicated? Yeah, let's.
I think for the first one, that's just like how many points are they worth? Oh, yeah, no, there is more there. You're right.
Yeah, but yeah, let's see the sum.
So we can sum, and I guess we'll also. This I always find very interesting, because some people they write this, and then other people prefer this syntax. I can tell that as when you're leaning more functional, I think you're also going with the more functional references here.
Yeah, I actually have printed function. It's an extension function on or on lists. So it's like there are two functions called .printed.
I see.
So, yeah.
Okay. So we can of course sum this, and it gives us a number. But as you've pointed out, this obviously doesn't take into account the scoring scheme yet.
Yeah, so I think it's like, well, let's extract a variable. So what I'm doing, there is a you installed this plugin. If you press F1, it's called the quick fix plugin, right?
I do want to advertise this here at this moment because I do actually also have it installed, and it is developed by none other than Dima here. So when I'm typing plugins,
just quick fix.
It's just called the quick fix plugin. And yeah, as you said, this just applies the first available quick fix. So it does say if you Alt Enter, and it just lets you hit like F1, for example, or I just have like a little dedicated button here that I mapped.
Yeah, so over time, like you develop intuition, what's going to be there at the top. So, well, I develop, and so I can just press F1.
Yeah,
it is a bit configurable. You can reorder things really, but I mean, ultimately, what would be nice is like, instead of all ID shortcuts, you just have one shortcut and ID and some machine learning magic dust.
Just a
figures out what you want. Yeah, just press one button. It's like autocomplete, sure. Like fix the compiler error.
I mean, I feel like honestly, like my personal dream would be something with eye tracking and then with voice input, so that I could be like, all right, fix that part, and we'll put this in a variable called that, and like
yeah, no, I agree. Yeah, no, F1 for fixing things, and for moving around instead of shortcuts, just eye tracking. Yeah, you blink and cursor moves, right?
That's right. And then you get something in your eye, and all of a sudden you can't work anymore. Okay.
Yeah, so I'll press F1, and that's going to be count.
Mm-hmm.
And then I think the logic was...
Sorry. Let's very briefly. I do apologize. Let's just undo that for a second. So if I were to do that here, it's because the highest most shortcut is introduce local variable. I would not have known that this was in here because my general strategy is like I press Control T and then I'm like var for variable. Of course, once you've developed that intuition, that's a lot faster. That's cool.
Yeah, that's a count, and I think the logic, if we do it in the long way, it's like if its count is 0, then it is 0, right? Mm-hmm. Otherwise, we do power of 2 or something. So the way I wrote initially was this, and then it's like count something -1 maybe. 2.
Yeah.
Do we need 2? Right. I think so. Yeah. Does it match what you have on the website?
It sure does.
Cool. Let's maybe write a test. So I think it's also lots of testing is about feedback, right?
Okay.
So we had fast enough feedback by just reading stuff, and then what's the cheapest way to write an assertion, right? It's just do a check.
Oh yeah.
So
that's a pretty smooth move.
So yeah, that's what I always do with these exercises. I think one thing I've seen which was neat is that this conversion to double and so on.
Mm-hmm.
There's like no hacky way to shift left. I mean, because
it's a 2. Okay.
Yeah, if you shift bits left, you multiply. If you divide, if you shift right, you divide. I wish there was power on integers, which does the same thing, but then I guess it's silent overflows, and nobody wanted to encourage that. So here I'm doing the same trick.
I was about to say, I'm like, I can see it. I can press the button.
Well, you can press. Okay, you press.
Yes, yeah, it's so nice. I just hit the quick fix, and you can even see the little note down there with the quick fix.
Oh no, we broke it.
Oh, now what happened here?
I think maybe it's this. No.
So
it's 1.
Okay.
I know it's 1. It's 1. That's why I think.
Oh, because you're just taking a single bit and then you're shifting it over, starting at...
Yeah. So you start and you don't shift. That's 1. I think it should work without this. Oh, no, it doesn't. Okay.
That's a negative. I'm seeing a lot of negative values here.
Okay, I undid it already. Okay, let's look.
Okay. So the only problem, I guess, or I mean, I suppose it's not really a problem when you're doing a simple check like this. But you are kind of missing out on a nice error message on check.
Oh yeah, definitely.
Is there one that can give you a nicer one? I know that for require you can provide a lazy message yourself. Oh yeah, actually this one also allows you to provide one.
I mean, in this case, it will print it on the line above, so it's like...
Yes, yeah, of course.
Sorry.
No, I'm just saying. There you go. Well, see, this is the problem. I'm so conditioned to, like, when tests fail, I'm like, I look at the red block where it says expected and actual.
Yeah. I think with this, actually, I think maybe we should be able to do this. Maybe I'm wrong. Let's try.
That does actually... I feel like that would make sense.
Some of that works. Oh, no. Why would it not? Maybe it's still -1. Okay. Hard to think now. Well, okay, let's give up on this.
But I think it were like, as long as you have the 0 check in it, I think it should be okay. I think that's the part that was the only problem, right? Never mind.
Yeah, no. Oh, what? At which point did it break? Yeah, this works. Okay. What about to do? Do you want to do windowed?
Sure, we can give that a try. Okay, so for this, I do need a tiny reference again, though, just to kind of see where we're at, because I think we need to have a... Okay, so we can't... This was just scrolled out of view. My bad. So we can't get around splitting on the first part. We do have to have these two. But I suppose it would just be, rather than having this split, our winning numbers would be the winning numbers text, and then that should be chunked. And if we're assuming that we didn't trim anything, so we'll begin at the first 0. So it's a chunk of size 3, and we don't actually need to skip over anything, because we can just keep the space inside, so that should be okay. And then each of the chunked elements, or each of those chunks, we should hopefully just be able to turn into an integer, and that is slightly shorter. So I suppose we could do this for, and again, I'll also do the our numbers text, and I guess that means we can get rid of these two. Would you do me the honor of running the test?
Please do.
And that does explode. Because...
I think it's stream, right? It's stream to int.
Sorry?
Maybe it needs a trim before conversion.
It sure does. I'm a little surprised. I would have thought that maybe
So sorry, I didn't help. I just thought we'll see. And on the other line as well, right?
Yeah, I mean that
on line 14 as well, I think you didn't.
Of course, yeah. You're right.
Yeah. But it's fine. It's just we'll see.
That still explodes.
Oh yeah, empty. So it had an empty chunk.
Now, in what scenario do we encounter an empty chunk, though? That I'm actually hold on. That I'm actually a little curious about because
maybe we need to trim text before as well. Because is it?
Well, it's supposed to be trimmed at the end there, so that should be okay. And since we start at the beginning, so it should also not it should not be a partial chunk at the end either. Oh, maybe no, it is. No, it is a partial chunk. Yeah. So there's a partial chunk at the very end. So we will do, I guess, a trim first. I'll do that on both of these. I have to say, well, now with these trims, I feel like we haven't really won much in like line length, to be honest.
Yeah.
We're also still not working. Okay. Oh, because that's okay. So this actually has to only be this should only be an end trim, I think.
Oh yeah, probably, yeah. But I guess that's the thing with all the refactoring. Just try lots of things, right? And then you try
I like
and then you back out.
Yeah.
Yeah.
But that works. Look at that. Or Herbert also suggests alternatively splitting on the pipe character with spaces surrounding it.
Yeah, that's actually nice, I think.
Is that going to fix it though?
I think so. You can add it now.
Yeah, I guess now that we have a test, I suppose.
Yeah, it just had spaces around pipe and around
we'll add
test.
spaces here, and I mean, then
just run it and then.
Yeah, you're right.
Yeah, and then you can delete remand probably.
I'm suspicious about that. That is not okay.
Yay. Maybe delete to do as well. We're done. We tried.
We are to done.
Yeah,
that's
cool.
great.
Also, like the other thing is like it's a functional style, but then it's like, oh, is it worth it? Could do this probably and just run it. But these lines were redundant, right? So,
yeah, because you were just like kind of feed forwarding it into the next function. Okay.
Yeah, so I can see also that our numbers is highlighted as misspelling or something. So
yes.
I don't know what it should be, but
should probably be singular.
Oh, okay.
But I disagree on that one.
Yeah, I agree with you that we disagree.
Yeah. Okay, but look at that. One part done. It's like we're 30 minutes into the stream. We're making great time. Now we just gotta... If this is a constant time for part 2, I'm sure it'll be great. Okay, but I mean, we're... are you happy with what we have here?
Yeah, it's good enough, right?
Okay. Very nice. I did enjoy this. My own code contained a bunch more loops when I first solved this, so I do like this, and I think I'm going to steal this fast feedback loop style thing because I'm a little bit more on a just submit and pray schedule.
Oh yeah, that's the other thing I was thinking. Like how it's the advent of code tells you is it high or lower? Could you do binary search in the background? Maybe it's faster in some cases.
But I think I don't think it always tells you whether it's higher or lower, right? I think
okay.
So I think if you're just off for the first like 3 tries or something, I think it just tells you that's the wrong answer.
Okay. Yeah, and there is a timeout.
Yeah. Okay, well, so let's have a look at part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have.
Oh, sorry,
specifically,
you've got your hat, I believe.
Oh my! Thank you. This is why it's good to have people that keep you accountable. Also, I saw Maya in the chat earlier, but she did not complain. So, what's up with that, Maya? I thought we talked about this. Thank you. Yeah, good call, Patrick. Thank you. So specifically, you win copies of the scratch card below the winning card, equal to the number of matches. So, if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10, it has 5 matching numbers. It would then win a copy of the same cards that the original card 10 won. Cards 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. This time, the above example goes differently. Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards. Cards 2, 3, and 4, and 5. Your original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Your copy of card 2 also wins 1 copy each of cards 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers, so you win 4 copies each of cards 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies, have no matching numbers and win no more cards. Your 1 instance of card 6, 1 original, has no matching numbers and wins no more cards. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6. In total, the example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards until no more scratch cards are won. Including the original set of scratch cards, how many total scratch cards do you end up with? Excellent question, I suppose. I guess line-wise processing goes out the window now.
Well, similar to the part 1, it's like if we actually think about what's going on, it's like, oh, there are scratch cards and you win more scratch cards, but there are no points. It's like, Elf, you don't need the scratch cards. You win nothing. That's the answer. Don't do that. Take us to the place, right?
Well, it's the journey that counts. It's the I assume there's no prizes at the end for any of this. It's to be fair, it is very satisfying to scratch off a scratch card. That's something I always very much enjoyed. It just leaves all this little residue that's kind of annoying to clean up. So, okay, all right. So now we have this kind of like feedback loop, and I guess we can see how much of our code we can adapt or we need to adjust.
In some ways, like what I do, I just copy part 1 into part 2. Also, in a way, in the problem description, like the story, they say, oh, actually, we were wrong. So all of this code, we could just delete it. It's redundant now.
That is very true.
So why keep it around? Let's copy it, but I just...
Yeah. I mean, for me, it's always a matter of I like having something to hold on to, something to remind me of where I came from. Okay, so I guess we'll extract this into its own part 1 function.
I was just. Do you mind if I just create a file? Maybe.
My hands are off.
Go.
I was just wondering, but while you do that, I do wonder if I mark all of this, would the first shortcut have been convert to expression body? I'm not sure about that one, IntelliJ. Okay. I really would have loved an...
So...
I guess that does work, in theory.
So I copied all of that into a different file.
Yep.
You can see. It shows that it's a duplicate something.
Of course.
Yeah, so... And what do we want to do? What's the approach in general?
That's a great idea. That's a great question. It's been one hell of a day.
I think one of the approaches I've seen is doing double loops. So it's essentially double loops, and we go through each card, right? And then
Yeah.
for each card, we count what's
Yeah.
come in and updated in some mutable data structure, which won't be so great, but could do that.
I think that is the natural approach that I would go for. And given and then it's a matter of if you're not up. Well, the question is, in that data structure, would you want to update just a counter of how many of those cards you have, or would you actually like copy the cards? Because I think I know it, like, so this morning I used it by just, well, I'll clone a bunch of cards, cross my fingers, and pray that the numbers don't become so big that allocating a bunch of objects isn't gonna bite me.
I did the same, and then if it works, it works, right?
Yeah.
And then you have a working solution which you can evolve. So absolutely.
So maybe that's the strategy we can run here as well.
Okay.
Potentially.
I'm in a different file now, which is day4_2.
Okay.
Yes, I copied this.
We'll continue here. Okay. Gotcha.
Okay.
Great. So I mean the logic up until, so the parsing logic stays the same.
Yeah.
That one we already had.
Could extract counts maybe into a function or something.
Sure. That sounds great.
Or maybe just delete it and move on.
But we do need the count, don't we?
We do.
We need the count. We don't need the scoring. So I'll start by doing. I'll start by contributing a lack of scoring. There we go. That's already something.
Delete line 15 as well then, because we don't know what it is, right?
Not quite yet. And I suppose one of these might.
Yeah. So yeah, let's try.
And we get
and
a lot of units.
Yeah.
So I guess we can already try. I'm trying to think if there is a way where we can still do this in a semi-functional way, or do you just want to keep it in like the?
We could do it in some way and then try and refactor if we get to it. So yeah, you wanted to. We want some mutable data structure, right?
Yeah, pretty much.
It would be like a hash map.
Well, I think it's just. Honestly, was it a list of mutable lists? We can generate one list for each card, and then as you duplicate it, instead of having a single element in it, you would just have multiple elements in it. Does that make sense?
Yes. I think it makes more sense to you. So I think could you type it so I can?
I'll give this.
Sure,
I'll give this a try. So at this point, probably the count doesn't matter that much, but we'll have. Again, I'm trying to see if. I guess this we would just map this to be a mutable list of our ticket, I guess. So maybe we do need like a container. So I'm just gonna quickly introduce one for
you mean it's a card, I think.
Oh yeah, sorry. This is the funniest part. If you look at my draft solutions that I write in the mornings, my vocabulary is all over the place. They're talking about cubes. I have like dice. There's cards. I call them tickets. It's it goes off the rails quite quickly. So we'll have winning numbers. And
our numbers, that's what we call them.
Yes, we do. I'm just thinking if we could get away with just
it's a list
storing
int. Right?
No. I was actually just thinking because there's actually no real point in parsing them out and then storing them. Well, I guess that also works. This is all fine. Okay, so we will just have a mutable list of our card with our winning numbers and our numbers. So this would kind of be the start, right? Like this is the data structure that we then can manipulate mutably.
Okay, I see.
And so this part we would then do as we mutate. makes sense, maybe.
I'm not sure where it's going, but yeah. What we'll be doing with the list will be adding the same card to it.
So exactly. That would just kind of be my idea. So if you have you have like your list of cards that originally just have the original, and then if this one has, let's say, 3 wins, right? Then so I guess I should A, B, C. Okay, well, we'll say if this has 2 wins. So if this has 2 wins, then we would copy, what is it, this card twice and this card twice?
Mm-hmm. But it's like the same card, right?
Yes.
So we could have a counter, actually. So
we could have a counter, or either works. Oh yeah, we could just have and so instead of having a mutable list here, our container could just be something with a pair of card to count, like mutable count.
Yeah, actually, like what you showed was, I think maybe that's not a bad thing to maybe. Like, what if we do this just to try? Would you like to visualize something? So we have a card and we have a count, right? And if I run this, we should on each.
Yeah,
we'll see all the cards, and at the end we'll see the numbers. Still hard to comprehend. You have an example though, right? I think in the project there is day 4 test. Maybe will be easier to comprehend.
It's a little shorter for sure.
Yeah, so that's what we have, and that's like I think this is a valid step, right? Nothing's wrong with that. So maybe we'll leave the thing at the top and say this is a card here.
Okay. Yeah, we can do that.
And this is count. So we don't need to change things above. That will help us, right? Yeah. But now here we could have something mutable and maybe. Oh wait, what am I doing? This is. It's not lat. It's like we're doing a map.
Same thing as before.
Yeah. So we could go. What would be the cards and count?
But see, the problem is like you want to mutate a data structure here. I'm not entirely sure.
No, yeah. What I meant, like we have it. So yeah, if we do that, it's essentially like having. I don't want to introduce global mutable things. So if we have a lat, it's a list of things. And this is where we can have a map like this, and then we can define something mutable here.
Okay, all right. Now we're on the same.
Right, and then since we I think we could get away with int array because int array it's like a hash map, but index is a key, right? So it will be a size.
Yeah. Okay. Sure. Yes, that's okay. You mean just for lookup speed, or like because just a regular list is also just like.
Okay,
it's also a hash map.
Absolutely. Yeah. Everything is. Yeah.
So,
well, you can.
Sure, that works. I mean, I'm
happy with hash map if you prefer.
No, I prefer list.
Okay, fair enough. So we'll do list.
I just remember
the only difference with list is like how we're going to modify values in the list.
Mutable list.
It will then we need to like replace it with this. It will be like this. It's a bad name, but you can do this, I believe. That will be easier, right? That's the advantage. It's like mutable.
Okay. Oh, I got you. Okay.
Yeah, so it's still working. We didn't break it. It's all returns unit, but maybe return it, right? It's good to keep things. So then we want something.
Sorry. So the only reason why I always react slightly allergic to int array is because I distinctly remember a tweet from Roman Elizarov at some point where he said like arrays are the most shameful part of the Kotlin design and they shouldn't be used.
No.
That's kind of the main reason, but they do have an advantage like you point out here. So
I think maybe it was in the sense that it doesn't work with all the APIs very well, and here it will be kind of hidden. It will be internal data structure to this lat. So
Olaf actually points out that mutabilist can also do ++. Well, now hold on there.
Okay, you try it then.
Well, no, well, I'm just curious about that one. Whoops. Which would just be.
Maybe.
And you wanna.
You,
well, you do want to initialize all of these with having one of these, right?
Maybe, yeah.
Well, the counter, since it's a counter, I think it should start at 1. Yes, I think so.
Maybe, yeah.
We'll see.
Yeah, no, that's fine.
So
yeah, one's reasonable.
I was light. Well, no, hold on.
No,
no, it's all good. I was just trying to. Okay, so if we click on this one, I'm a little suspicious on that one, because this just seems like a regular. That just seems like a lookup and increment. What about plus equal 1? Intrinsic.
Let's print map and run, right?
Yeah.
So it does work. So we're printing each map. We should do 2.
No, it doesn't.
It does work.
It really doesn't. I did a plus equals and it works. How? Oh wait, no, this does.
Yeah, I modified it a few times. So it does work.
Okay. So it does work. You can have that as. Oh my god! I just ran the wrong file. That's terrifying. I'm sorry. Give me. Here we go. Okay. Yeah. So that does work.
Yeah, I don't mind mutable list. Yeah.
Sure. Let's do that then. Great.
So we should call it something else, though. It's more like count by card, right?
Yes.
So, okay. Count by card. We look at card index, really.
Yeah.
So, yeah, then what do we want to do? We have count for the cards.
Okay, hold on. Is this the count? I'm sorry. I'm sorry. I gotta look up. I gotta put this maybe on my second screen or something. But yeah. I gotta look up the description of this one again. Actually, I'll do it out here. So it was the points. There's no points. You win more scratch cards equal to the number of winning. Equal to the number of winning numbers you have. Okay.
Yeah, so we know the cards, right? We just want to update these count by card, right? We know for sure we want to do something with this. I think what we need here is really index on the card.
Yeah.
So there is this, you can alt enter and it does this, convert to index. Should have the index of the card. And then we want to do something like increment by count.
That sounds about right, except that we should
repeat this.
Yes, we should repeat.
Count is not the count, right? We're going, it's a range. So count is how many other cards, and for each of them we do increment. Yeah,
that's right. So I guess this would just be either a repeat with an offset of +1 or just a for loop for an offset range.
Maybe it could be a range, I think, like this. Yeah. And we do for
You are more functionally inclined than I am. That is so that's so much nicer. I like that. So just for context, the equivalent code that I probably would have intuitively written would have just been repeat count, which goes from 0 up to non-inclusive count, and then you could have done count by card. This gives you the index, so you would do like it +1 and then plus equals 1, which it's fine, it works. It's just yours is actually, I think, more expressive, so I do like that. Okay, nice. And
I think the interesting thing, we don't need cards here. There is IntelliJ suggests to do something, but maybe let's run this first to see. I think I'm sure it's incorrect, but just to see that it doesn't crash, because we're doing like index on line 24. So sometimes that blows up. And I don't think it's +1. Like we want to. What do we?
You add the. Let's take a look again. You win copies of the scratch cards below the winning number. So if you have 5 matching cards, you would 1 copy each of the cards. So that actually, like, the plus equals 1.
Oh,
that seems fine.
Wait.
It's just that we need to probably offset slightly different.
Yeah, offset. I added +8. So yeah. So which will be index of the card, I guess. Is it? No. Not sure what a good name would be here.
And sorry, for what? For the outside one.
Maybe rename outside one to pairs.
Yeah.
I just did because ran out of name. Let's see how that looks. And in the example,
side by side, I guess. I mean, so probably the easiest would be for us to sum this up as well and see if we get 30.
Yeah, I don't. Just looks a bit suspicious for some reason.
Yep.
Nice.
yeah. It's very funny. I can see Olaf becoming irritated here. I think the number of question marks in the chat are becoming more. Why don't you just add count?
Why?
But I think that's this offset as far as I know. Oh no, he means so instead of having this loop, why don't we just go into instead of the loop, why don't we just add that number directly? Because all we do is take the same thing.
Yeah.
Actually, no, but we're no, because this uses
no. Oh yeah, that's the problem. We should do count by card and get the current index, I believe. Because this is
because we're cloning the current one. That's a good point.
Yeah. Like, I think it's this.
That looks correct.
Yeah, that's why. Yeah, it was right. Like while loop. Yeah, because we have the current card, let's say 10 times, and then we want to increment all the following cards by the same amount of how many current cards we have. Right. That's why it's this.
Yeah.
Right. Okay. Then let's remove test and run it on the whole thing.
And that gives us 555,000. Sorry, 5,554,894, which is correct.
Woo! So
that is very nice.
I added this assertion in the end. Yeah. So yeah. Do you want to try and refactor any of this?
We can take. Let's. You know what? Let's put it to chat. Okay. Well, I'll make sure that the whole implementation is visible on screen. And now I'd love to hear from all of you. What do you think? Which parts of these could be improved? This up here is just because it's a duplicated line fragment. Just so you know. That's the only way where there's a warning.
I think one thing I've seen with like the best solution I ended up with today after a bit of reflection, I don't know if it's a spoiler alert, but I initially did a recursive version, and then with recursion sometimes it's like kind of hard or like not obvious, and then it's like, what if you reverse your list? And then it becomes really easy. So that's one of the heuristics for solving this kind of things. And then it's quite interesting. If you reverse the list, you can just do one fold, which is pretty cool. I didn't sorry I didn't say that in the beginning. We did it the hard way.
Oh, that seems fine. Oh, yeah. I wouldn't even consider this the hard way. Like the hard way is copy pasting the string over and over again.
Yeah, what I think we could do, like what I try when I do this kind of stuff. So I'm just adding let above the solution, so everything works, right? I can still run it. Yeah. Then we have this, let's say call it pairs again. I really don't like this name, then well, whatever, we'll go with that. Pairs. And then we can try and do it. I'm not sure if I'll finish, but if I don't, we can just delete the code, right? So we can do reversed, and then on the reversed we want to fold, right? And the initial thing is that we have an empty list.
Okay.
And then the vote are complete. Yeah, I have accumulator and a pair with card and account, right? Let's return accumulate. Oh, why is it not happy already? Do you understand why it's not happy?
Because you have pairs and you. Oh wait, I don't understand why it's not happy.
That's card. That's count. I just cannot see in code with me. Press control.
Yeah. Yeah.
Empty.
It just straight up. Yeah, it just doesn't.
Okay. Okay. It's a type inference. Yeah. That's fine, right? That's the.
But I like one refactoring hint here from William in the chat, which who says, if we split on, rather than having two spaces here, if we take away this space, then apparently the entire conversion to int is no longer required, because I guess they'll all have a consistent formatting. So you could just work with the strings directly, because we don't really use.
Should we just do it? I mean, let's do it if someone's doing it.
Sure, yeah. Is your we can do this?
Well, my experiment is still there. You can always do it. Yeah, it's not ideal, right? We haven't finished one thing, started the other.
Yeah, but I mean, since we might as well.
All the types. No, let's not do that.
Sorry. Okay, fine. Well, yeah, we'll do that first, and we'll make sure I'll introduce that again. Okay.
Yeah. So I think with this, we should be able to get away with we know the count, right? And we want to prepend it to. Well, let's prepend it maybe to play so.
Now this one I'm very interested in, because I'm not.
We can also just print it, right? So just to know what's going on. Maybe it's better now. So let's just do also. I want
you'll have to walk me through again why doing this puzzle or why doing that list in reverse improves the situation.
I think it's because you don't. If we start from the end, right? So you have examples. Can you see the cursor? Oh,
let me. Yeah, sure. I'm on your cursor now.
Oh no, it's in the first day, day part 1.
Mm-hmm.
Oh no, it's not clear as well. Okay, maybe we should just start with. If I do pairs, we do pairs and print. We do for each. Println needs second, or maybe map, and that's println. Sorry, it's getting a bit. Well, I don't know where that is.
Here we go. Okay. Which maybe on the test case.
Yeah, no, it's hard. It's hard now to understand what's going on. So what I mean is that if we start from the end, well, the last card, it will not have any following cards. So if we do the count on it, we're fine, right?
Yeah.
So no, this is not the whole solution.
Sure, yeah.
But then for the next card, once we step the card before the last one, we should be able to look at the following card, and we know it's already all done, right?
Okay.
So
then it just becomes a matter of multiplying a couple of things?
Or adding them. So, and we have all the counts at the tail in the ACC accumulator. So what we can do, so we have the current card. So we have a range, let's say, to count. I'm not sure. I think it should be like this because our current count is still not there, and then we can do sum of, and we'll look at an accumulator. So we're looking at all the cards past our current card, and that will be the count here. So I'll do F1, and it will be, let's say, let's call it sum, and that will be all the cards past the current card, right? So it's not the sum, it's the count for our maybe that's what should go into the current card. That's how we calculate, right? I think that should be something like that. So this sum goes into here. Let me run it and see what happens. Oh, we need a small example, right, to do it, yeah. Because it's easy to comprehend.
That.
I think we need to count the current card. That's why I did L1 plus. And
I have to say I'm a little bit in the same boat as Johnny here. Just posted the exploding head emoji.
Oh, wait a second. Did I break the check somehow? To which point did it break? Oh, okay. 1 plus was.
Okay.
What? Oh, why is it? Sorry, I'm confused. Is it like just bug or does it run? No. Oh, everything runs, right? Just IC1 is red. This is interesting.
Me too. This.
Oh, okay.
Oh, well, now it's gone. Okay. Just a little hiccup.
I think it works, Rick. This logic, these numbers match at the top. Oh, yeah, sorry, you can't see what I see in the toolbar, and I keep forgetting.
Oh.
So I think it worked, basically. And I think the logic is that you start from the end, and you know that whatever you put as a sum for the last card is definitely correct, because it doesn't loop around, right? And all that. So,
okay.
Yeah.
Yeah.
So now, like, just to be a bit more cautious, let's just comment this bit out. Oh, the sum was okay. I'll delete that. Sorry. Let's run this again. Oof. What's wrong? Oh yeah, that thing. Yeah, so this works now. I don't know if you've seen it. Sorry.
Yeah.
Full window. So all I did basically commented out that other code we had. And
give me just 2 seconds here.
Yeah.
There we go. Okay.
So and it passes the test. So that's the thing.
Yeah. Okay. That is of course slightly more elegant. Would also take me a cool minute probably to understand what's going on in this one. But I can make a contribution here. I can put my cursor on this one and I can press F1. So that so now I'm I'm a core contributor to that part of the code.
Yeah, and it's pretty cool because now we could say, oh, actually we don't even need pairs. We only need counts. We don't even care about cards. It looks like if you see pairs, we reverse them, and then we kind of just drop the first half. So
yeah, we really do.
Maybe that's another refactoring to do.
Which would be
that's
cool.
So, I ended up with this approach. I have to try a few approaches today. But also someone mentioned it on Kotlin Slack that if you reverse it simplifies things.
This is a super clever approach, I gotta say. Wow. Not sure if I could come up with that one before my first coffee. This is quite a delight. I also realized that I'm, I get to pick and choose whether I have my brain power for solving the problems or for solving the streams.
We have 12 of them, so yeah, to be fair.
It's but this, I'm still a little bit in awe just looking at this, which is quite cool. No, this is really awesome. Wow. Okay. And we did actually make okay time with this. Well, we're still roughly within the hour. If it were a conference, probably the organizers would have kicked us off the stage by now. But we're a little bit more flexible here.
Yeah. If we practice a few more times, we could do the talk at a conference.
Yeah. But actually, speaking of talk, I will use this segue now that I have it. I do actually want to shout out something, because if you're not familiar with who Dima is, I would very much encourage you to watch his talk from this year's Kotlin Conf, the Gilded Rose Refactoring kata, which is just Dima being an all-around IntelliJ ninja. I think it's a very satisfying to watch video. It has taught me a couple of new techniques, for example, exploring code by just collapsing everything and then stepping through on the different layers of abstraction, which is something that you do in this one. It's something that I sometimes did, but this one kind of showed me the proper power of approaching unknown code that way. and also just a very, very solid understanding of how IntelliJ works, which is like, it's a delight to watch. I will actually, I'll post a link to this since we are wrapping up, and y'all probably are looking for something else to watch. I'll make sure we have this one in the chat as well, so you can go take a look and maybe even leave a like. It's a very good time. How did you get in? Actually, just as we wrap up, how did you get inspired to do this talk at KotlinConf?
I did Gilded Rose Kata at some meetup more than 10 years ago, and I just thought there is not enough attention to refactoring. I wish there was more refactoring tools, even a library. You know, that's just metaprogramming. If you want, you could define a function which takes a bit of Kotlin code, parses it, produces another Kotlin code which is still valid, and so on. You know, why people are not excited about it.
Yeah,
that's, I guess, the main motivation. And, just sharing this exercise, although it's kind of overused, I guess.
So you said you've done this like 10 years ago. I know that katas are like a thing that you're supposed to like revisit every once in a while. Like, is this something that you've done? Like, is this something that you do regularly, like to train, or is it like, does it just come up sometimes? You're like, oh, it still is an interesting puzzle to see how to make this nicer, or how does that work for you?
I think it's more on circumstantial, just meet up, and I used to pair program with people at conferences and different things. So, yeah.
Okay, all right. But yeah, there's already here good feedback as where William says, I was there myself and all my colleagues really liked your talk.
Thank you.
That's really awesome. And of course, I mean, I have now learned, and so I did not have the quick fix plugin installed before today, but I'm not going to uninstall or disable this anytime soon, because now I have tasted the power that pressing a single button to just apply a fix gives me, which is save one keystroke. But it adds up, I guess.
It's not just a keystroke, right? It's mentally, unloading certain things. I think there is an interesting podcast with Brian Merrick, Oddly Influenced, and he mentions that idea, which I like, is that lots of the refactorings, it's not like you just immediately come up with this. You need to experiment, and to experiment with this, you need a good environment. So it's a bit like tactile, that's an analogy they make. So you need to play with the code to get into bigger insight, I think. And that's why, like, it's not just one shortcut. It makes exploration easier, and that guides you to better insights into refactoring, which kind of takes you to the core of the problem. It's like, like if you just want to submit a number to Advent code, you just like do it manually, right? But if you want like discover how the reality works and things like that. So I think it's a deeper thing. There's small things, they all add up on a psychological level, and that's why it helps. That's
honestly a really cool philosophy, and something I hadn't quite considered. But you're totally right, like 100%. If you can take your code and you're in an environment where you can knead it, you can like squeeze it, you can like change it around easily, and the tools get out of the way for you, I guess you much quicker arrive at a point where you figure out what are the constraints, what are the things that are like, that you can change or that fit your brain wires well. All these kind of things. That's a really nice way of looking at things. I think I'll try approaching one of the future Advent of Code puzzles in a similar way. I think that might be quite an interesting exploration. All right. Well, thank you so much, Dima, for coming on the show. It's really a delight to have you.
It was fun.
As usual, thank you everybody who decided that they were going to spend their Monday evening, afternoon, whatever time zone it may be, with us. It's very much appreciated. And I would, of course, love to invite all of you to come back tomorrow, where we will once again have a guest with an entirely different perspective on advent of code. And who knows, maybe we'll even see a totally different way of writing Kotlin code in IntelliJ. That might be quite interesting. So make sure you don't miss that. Make sure you come back tomorrow. Make sure you spend a little bit of time puzzling with the problems yourself. You don't have to solve all the problems, but it's always good to like give him your best shot, and maybe you can learn something while doing so. So yeah, thank you everybody very much for tuning in today. I'm not going to give you the typical outro spiel of making sure that you can win a couple of prizes and the like. But yeah, I just wish you a wonderful week, and I do hope that we will see you again soon. Have a lovely day. Take care, everybody. Bye-bye.